Alright, so in this video I'm going to be going over 5.2, right triangle trigonometry. I am finishing up what we started yesterday. Hopefully I will be feeling good enough to come back to school on Monday, when we'll be working on graphing sine and cosine functions. So today we are focusing on identities. We have reciprocal identities, which I kind of talked a little bit about yesterday. These are identities where one of the trig functions is related to another by a reciprocal, so that just means it can be rewritten as a fraction with one over the other trig function. So we have sine and cosecant are reciprocal identities, and that can be seen in the first two. Then I have cosine and secant, those are reciprocals. And tangent and cotangent are also reciprocals. So then the next thing I have are quotient identities, and it's when I relate two identities together as a quotient. Remember, quotient's just another way of saying fraction. So I have tangent, can be rewritten as sine over cosine, and we talked about that one a little bit briefly yesterday when I had the red sticky note. And then I have cotangent, because it's a reciprocal identity of tangent, it flips the fraction for tangent, so it's cosine over sine here. The last ones we have are Pythagorean identities, and these relate the trig functions to each other using the Pythagorean theorem, which, if you forgot, was a squared plus b squared equals c squared. And then one thing I want to note is if I write sine squared with the exponent right here, it is the same thing as writing this in parentheses. But if I was to write sine theta and then the theta itself was squared without the parentheses, that means something completely different. It means I'm actually taking that number value for the angle and squaring it. So these are the only two appropriate ways to write sine squared if I mean the function itself is squared. Okay. So I have a few examples I want to work through. It says let theta be an acute angle such that cosine is 0.8. It wants me to find the values of the trig functions below using the trig identities. So remember, I mentioned that in geometry you learned about sine, cosine, and tangent, and you might have learned a mnemonic to remember it, SOHCAHTOA. So this is helpful for when I'm given one trig function and I want to find the values of others. Cosine is relating the adjacent side of a triangle to the hypotenuse. So I am going to sketch out a triangle off to the side of my paper. And then cosine is my adjacent side over my hypotenuse. So my adjacent side is right here. I'm going to make this 0.8. And remember, I can always turn anything into a fraction. So I can rewrite this as over a 1. So I have that. Because we are talking specifically about right triangle trigonometry, I know that this is a right angle in this corner over here. So what I want to do for A is I want to find the value of sine. Remember, sine is opposite over hypotenuse. So this is adjacent, opposite, hypotenuse. I am searching for this missing side length, so I can go ahead and divide by that 1. So what I want to do is I can make this an unknown variable, x, and I can use the Pythagorean identity here to solve for it. I'm actually not going to use that x. I don't know why I said that. So I was just showing you a visual representation of what's going on. I'm going to actually use my Pythagorean identity here because it says to use the trig identities. So I don't know what sine squared is, but I do know cosine is 0.8, and I want to square this, and it should equal 1. So if I go ahead and get my calculator out, 0.8 squared is 0.64. And then this still equals 1. So I can set it equal to 1. Then what I want to do is I want to go ahead and subtract that 0.64 from both sides. And I get sine squared equals nope, not 0.64, I forgot to do the math. 1 minus 0.64 gets me 0.36. Because this is squared, I want to square root it to figure out my value of sine. So if I go on my calculator, I go second square root, 0.36. which gets me 0.6. So sine of theta equals 0.6. So I got a little bit ahead of myself with this triangle. I was trying to show you that the reason this works out is because of the Pythagorean identity. So if I just plugged in, that would give me 0.6. Again, I could plug in these values and solve. So I have 0.8 is my cosine value. And then over here, this unknown value is my sine squared, or my sine, which turns into sine squared. And the 1 was the tangent value. Okay. Or no tangent value on this one. The 1 is just the 1 over here. So on B, I have tangent. I can go about this using the tangent the quotient identity for tangent, where I take sine of theta and divide by cosine of theta. So I know these two values because I was given cosine and then I found sine. So sine was 0.6, cosine was 0.8. Then I want to go ahead and just simplify these so I don't have two decimals in my fraction. I'm going to do 0.6 divided by 0.8. I press enter, and I'll move this out of the light, which gives me 0.75. I can go math, and then press enter. And press enter again to get this as a fraction. I don't know why I did that. I didn't need this one as a fraction. 0.75 was good enough. So same idea for number 2. It tells me the tangent of theta is 1/3, and it wants me to find the values of the trig functions using trig identities. So cotangent is the reciprocal of tangent. Then I want to go ahead and plug in. So this is really 1 divided by 1/3. I can either do this by hand, or I can type it in my calculator. If I type it in my calculator, I'm going to want to make this into parentheses. But I'm going to do this by hand. So I have 1. Because it's being divided by 1/3, I take that fraction and flip it. So now it's 1 times 3 over 1. 1 times 3 is 1. Divided by 1 is 3. Okay. So now I want to go ahead and find secant of theta. I have tangent and cotangent, so I want to take a look at my identities and see what I have that relates secant to either tangent or cotangent. So secant is related to cosine. Reciprocal identities are not helpful. Secant doesn't show up in the quotient identities. Not helpful again. Secant is related to tangent by this middle Pythagorean identity. So I'm going to use this one to solve. I'm going to write it down here so I don't forget it. I have 1 plus tangent squared theta equals secant squared theta. Then I want to replace my values that I do know. So I know tangent is really 1/3. So now it's 1/3 squared equals secant squared. Then I want to actually go ahead and solve this out. I have 1 plus 1/3 squared is the same thing as 1/9 equals secant squared theta. I'm going to go ahead and add those two on my calculator. 1 plus 1/9. If I go math, fraction, enter, gives me 10/9. I'm going to leave it like this for now. Only because I needed to take a square root. So whenever I am given a fraction, I want to make sure I stay in fractions. So because the problem originally gave me tangent as a fraction, I want to leave it as a fraction, whereas on number 1, it gave me it as a decimal, so I'd want to change it to a decimal. Then going forward, I want to go ahead and square root both sides. I cannot simplify the square root of 10 any more than that. So it's going to be the square root of 10. But I can, however, take the square root of 9. The square root of 9 is 3. So my answer here is secant of theta equals the square root of 10 thirds. So what I'd like you guys to do right now is pause the video, take a few minutes to work on 3 and 4, compare your answers with those around you. Once you guys all decide that you have the same answer, you can go ahead and resume the video and continue watching to get the rest of the notes. So on numbers 5 and 6, what I'm doing here is I'm using trig identities to transform one side of the equation into the other. This is kind of like doing proofs without writing my reasons. So I'm still writing my steps, but I'm just not writing my reasons. When I am transforming one side of the equation, you might also see this called verifying. You are only working with one side of the equation. Once I pick a side, I have to stick with that side and follow it through. I'm not going to go ahead and flip sides. Once I pick a side, I'm only changing the one side. What I personally like to do when I'm using, or when I'm verifying or using trig identities to transform one side, is I like to actually pick the side with more things on it, because that way it gives me more to work with. When I have one, if I look back at my trig identities on the front page, there's a bunch of things that I can use with ones. So I really want to stay away from that, and I want to turn everything into sines and cosines whenever possible. When we start working more with verifying trig identities specifically, we'll get into that, but this one's just kind of a little intro to that. So if I go back over here, this one wants me to use the trig identities to transform one side to the other. I'm going to work with my left side, because like I said earlier, this one has more pieces to work with. And I always want to turn it into sines and cosines. So cosine of theta is already a cosine. Secant is the reciprocal identity of cosine. So I'm going to rewrite this as 1 of cosine over theta. And then because I chose to change the left side, my right side is going to stay the same. As I work through this, I'm going to keep rewriting my right side down. I'm just going to copy that right side down. Okay, so then if I take a look at this, notice I have cosine of theta times 1 divided by cosine of theta. Anything divided by itself cancels out. I am going to just show you that cancels out, but I would actually leave this step written like that. And then I want to rewrite this, showing that those canceled out, so 1 equals 1. Whenever I'm transforming one side of the equation, or verifying, as it may be called, the answer is all of my work. There is nothing to box here, because my work is all of my steps showing me how I get it to equal the other side. So that is my final answer for number 5. Number 6, again, I want to pick the side that looks more complicated to start off with. And for this one, because I have two binomials being multiplied by each other, I actually want to multiply these together to see if I can use a Pythagorean identity, because those use squareds. So I'm going to distribute secant of theta times secant of theta will give me secant squared of theta. Secant of theta times negative tangent theta will give me negative secant theta tangent theta. Tangent of theta times secant of theta will give me positive secant theta tangent theta. And then tangent theta times tangent theta, or positive tangent theta times negative tangent theta will give me negative tangent squared theta. And this is a little off my screen, so let me adjust here. Then I have it still equaling the right side because I've chosen to change my left, so my right side will stay the same. This still equals 1. For my next step, I want to go ahead and combine like terms. If I look, my middle terms will actually cancel out. So I am just left with secant squared theta minus tangent squared theta equals 1. So what I want to do next is I want to see if I have anything that can relate these two together to equal 1. Otherwise, I'm going to want to turn it into sines and cosines. So I'm looking for something that has secant and tangent together, preferably when they're both squared, which if I look, again, is my middle identity. So what I'm going to do is, this is equaling secant squared. I am going to replace secant squared in my problem with 1 plus tangent squared. So instead of having the secant squared right here, I'm going to replace that with 1 plus tangent squared. And then I'm going to subtract the tangent squared theta that equaled 1. So this part of the equation didn't change. All that I changed was I turned secant squared into 1 plus tangent squared. Then I want to go ahead and keep simplifying. My tangent squareds now cancel out, so I get 1 equals 1. Because this is true, I have transformed the left side into the right side of the equation here. So again, I'd like you guys to pause the video, take a few minutes, work on 7 and 8, compare with those sitting next to you. Once you guys all agree on the same answer, resume the video for the last few problems here. So, down below, I have a few word problems. These are talking about angles of elevation and angles of depression. Angles of elevation is looking up, so like you're elevating someone, you're looking up. Angle of depression is looking down, so when you're depressed, you're feeling down, you look down. So that's how I remember those two words. Number 9 says a surveyor is standing 50 feet from the base of a large tree, as shown. The surveyor measures the angle of elevation to the top of the tree is 71.5 degrees. How tall is the tree? So, it doesn't really show the guy here. He is standing right here. But I do know that right here, this angle is 71.5, and he is 50 feet away from the tree. So what I can do is I care about how tall this tree is. So if I think back to opposite, adjacent, and hypotenuse, this 50 is the adjacent side. This x is not h. I was thinking height, but that's not the letter I wanted. This is opposite because it's not touching that angle. And then the hypotenuse doesn't matter in this problem. So I want the trig function that relates opposites and adjacent sides together. That is, if I remember SOHCAHTOA. Opposite and adjacent is related by tangent. So I'm going to use my tangent equation. I actually know my angle measure here. It's 71.5. My opposite side length is the one I don't know. This is x. And my adjacent side length is the one I know, which is 50. So what I want to do here is I want to isolate my variable so I can figure out how tall this tree is. I am going to, because if I just look at this like a normal problem, I have x divided by 50 and I want x to be all alone. I am going to multiply both sides by 50 to get rid of that fraction, which will cancel out right here. So then what I want to do is I want to type this into my calculator. I want to make sure I'm in degrees. Remember, if I'm using a new calculator, it will tell me at the top of my calculator. If I'm using an old one, I need to go to the mode menu to see. So both calculators, you press mode, you scroll down to where it says radian or degree, you highlight degree and press enter, and then the word degree should either be flashing or a solid black. Then you go second mode to go back home. I know I want to be in degrees because this problem told me 71.5 degrees. So what I'm going to do is I am going to type in the left side of my equation, 50 tangent 71.5, which gives me, I'm going to round to 1 decimal place because this one didn't tell me where to go, but it gave me a number that was rounded to 1 decimal place already, so I'm just going to use that as an indicator of where to round. This gives me 149.4, and we were measuring in feet. So that tree is about 149.4 feet tall. Okay. Number 10 says you're 200 yards from a river. Rather than walking directly to the river, you walk 400 yards along a straight path to the river's edge. Find the acute angle theta between this path and the river's edge. So I don't know about your copies because they're going to be in black and white, but mine do not look so great here. The 400 is right here, the 200 is right here, and the theta is right here. There is a right angle right there. It wants me to find my angle, so I want to first figure out which trig function is relevant here. I have, let me label, I have my opposite side, and I have the longest side because it's across from the right angle, so this is my hypotenuse. So I have opposite and hypotenuse. This is my sine function. I don't know my angle, so I'm going to use theta. Opposite over hypotenuse is 200. Then what I want to do is I want to get my angle isolated. The way I do this is I use inverse trig functions. So the opposite of sine is inverse sine. This always goes to the left of the function. So this is really sine to like a -1 exponent. So I'm going to rewrite this so you can see what I'm going to be typing into my calculator. And again, you should have done this in both geometry and algebra 2 last year. So, nope, I did not mean to click that button on my calculator. So what I want to do here is if I notice above sine, cosine, and tangent, there are little blue words on my calculator. I can't remember what color they are on the school ones, but they are a different color. They should be the same color as your second button. You just press second, and I want the sine inverse, which is right above my sine. So I press that, and then I just want to type in my fraction, 200 divided by 400, which gives me 30. So my answer here is 30 degrees. Whenever I'm looking for theta, I should always give my answer in either degrees or radians. This question didn't specify, so it's okay to give it in degrees. So what I want you guys to do right now is work on that last practice problem, compare with everyone at your table, and then go ahead and work on the assignment. Before I end the video, I'll rewrite these numbers because on mine they're not so hot. This is 19. This is the letter Y. This angle is 64.6 degrees, and there is a right angle right here. So, make sure you work on the homework, and then hopefully I should be back to see you guys on Monday.